Hello, everyone. I want to thank you all for attending my talk today. The talk's title is Increasing Your App Confidence Using CI/CD and Infrastructure as Code. And in this talk, I'm going to basically speak to how you can leverage continuous integration and continuous deployment along with CI/CD, or along with infrastructure as code to basically implement tests that can figure out if your deployments are broken after they're actually deployed to target environments. In any case, here's an agenda that I put together for this talk. A real quick intro into myself and what I do at CircleCI. Then I'm going to jump into a very brief discussion around testing, and then we're going to jump into talking about broken deployments, right? And finally, I'm going to discuss how you can increase your app confidence within your releases using CI/CD and infrastructure as code. And then I want to end with a demo that will kind of show all those concepts in action. So my name is Angel Rivera. I'm a developer advocate at CircleCI. And essentially what I do at CircleCI as a developer advocate is engage the community at a grassroots level. So when I'm engaging the community, I'm discussing all things technology, right? Doesn't matter if it's CI/CD related or DevOps related. I'm interested in learning about how folks, especially developers, are using technology and some of the troubles that they're having with technologies as well, right? I've been in the industry for a good part of 27 years now. So I do have quite a bit of experience, and I like to kind of, share some of my experience and knowledge with the community, right? Especially when they're struggling with things. And by the way, I'm also learning from everyone as well, right? So it's not a one-way street where I'm just like, dumping data or my experience on the folks. I'm also learning from other people's experience. And with those learnings, I bring them back to CircleCI so that we can leverage that information in determining the next features that we're going to build so that we can add value instead of just, building features just to build them. Anyway, so if anyone's interested in having conversations with me after this talk, you can hit me up on Twitter. My Twitter handle is @punkdata. Generally, it's the easiest way to get a hold of me these days. So please feel free to contact me and discuss whatever it is that you want to discuss. I'm open to all kinds of conversations. All right, so the first thing I want to talk about is testing, right? Because we leverage testing to basically understand how our applications are behaving and also understand if they're behaving as we expect them to, right? So we have to implement tests in order to understand and compare the results that we're expecting, right, from our applications. And of course, right, we have to create test cases. And when we're comparing those results, we want to make sure that, again, we're getting the results that we are expecting per the system requirements or the business requirements, right, that we're automating within our programs. There are multiple types of testing, though, right? So not all testing is equal, so to speak. And here's a nice list of some of the more common tests that we run as developers or that we develop as developers. The first two I want to talk about is the unit test and smoke tests, which are basically tests that are designed to be limited in scope, right? They're focused on specific functionality, and what we're doing there is trying to suss out any kind of common bugs or bugs that are kind of, common pattern or common practice bugs, right? So things like, does a variable, is a variable's data type or the values that the data type has or the variable has, are they integer, string, right, float? Are they compatible within the framework? Those are the kind of things that we're testing. We're also testing maybe for OK200s on a server, things like that. They're very limited scope. Focused on specific functionality and specific use cases. And also they're designed to be super fast, right? Like we don't want to be testing things at a comprehensive level, right? So again, these unit tests and smoke tests are designed to be fast so that, again, we're getting a nice warm fuzzy around the code that we're building. And most of the time, these tests are great for kind of ensuring that any kind of breaking changes are quickly identified and can be quickly mitigated. So after speaking about those fast, limited in scope type testing, I wanted to talk about functional integration and regression tests. Again, these tests are larger in scope, meaning they are more comprehensive. They will touch a lot or test a lot more of the code to ensure that you're getting the expected results. Generally, these types of tests are slower, right? Because they're more comprehensive, right? Because they're doing a lot more things. They're maybe connecting to other services that your application uses. One of the other kind of values, or actually disregards one of the other factors is they're very expensive, and that what I mean by that is they can cost. They can be expensive financially. They can also be expensive, in regards to manpower, like developer or operations team type time, right? So, like if you have these tests running, maybe someone's monitoring them because of while they're running, because of some of the intricacies of these tests. And again, they tend to be slower, more comprehensive tests, and these are okay, right? Like, so these are things that are running, I would say, more of an end-to-end type of experience, right? So that you're fully encompassing all the functionality within the application. Now, the reason why I bring these up is because I wanted to start talking about smoke tests, which are essentially the tests that, again, are super fast, limited in scope. And I'll tell you a quick story before I get started. When I was a teenager back in the day, working in a construction company during the summers, right? I would work with folks in construction. I actually got paired up with a plumber, and the plumber was there, basically putting in new plumbing into this new facility that we were working on. But when he was done, soldering all the copper piping and making sure that the water pipes were complete, he ended up connecting this smoke apparatus, right? Like a smoke machine type apparatus. And I was curious as to like why he was doing that. So I asked him, and he basically told me that, well, if I were to fill these pipes with water to test my, connections and make sure they were sealed properly, it could potentially be a big mess, because if he had a leak in some of his couplings, right, or they weren't soldered properly, there could be water spraying all over the place. So in essence, what he was doing was this smoke test, right? He was connecting the smoke machine apparatus, pumping smoke through it, and it was a clean, easy, quick way for him to figure out if there was any leaks in his connections. And the way he could tell was obviously if the smoke was seeping out of any of his connections, then he knew exactly where to go, right, to fix the problem. And that's what I just wanted to share that with you, because every time I see the word smoke test, it kind of reminds me of that experience as a teenager. And later on in my career, it kind of made that connection, right? Which is pretty funny in my case. So again, right, smoke tests help you with your preliminary testing, helps you reveal any types of failures, right, that are not expected. Again, super fast and very focused. Now, again, it's essential because, right, it's giving you the opportunity to, again, verify that your code is functioning as planned or as expected. And it also helps you eliminate those more expensive, long-running comprehensive tests, right? You can run those at a later stage in your software development cycle. So now that we kind of covered testing, smoke testing in particular, right, being quick, fast, and focused, I wanted to talk about broken deployments. Now, with broken deployments, right, we should be able to leverage continuous delivery, which is the practice of build, testing, and delivering changes to code using automated tools. Within continuous delivery, we have this concept of continuous integration and continuous deployment, right? CI/CD. No news there. I think a lot of folks understand what that is. But with the practice of continuous integration, all you're doing there is basically collaborating around code with your organization's teams or your coworkers, right, or your team members. And essentially, what you're doing is merging all of the developers' working copies or changes to a shared code repository, so that you're able to collaborate around that code as a team, and also the individual developer can get quick feedback on the changes that they made, right? So when you push some code and it's running through your CI/CD pipeline, you can do all types of testing, all types of verifications, all types of compilation, any action that you need to automate, and then you're able to kind of get that super fast feedback, so that you can actually go fix the problems that are identified within the pipeline, and then go back to working on the code that you're supposed to be working on, the new stuff, right? So with continuous deployment, it's just kind of I would say, a follow-up to your CI with continuous integration processes. And essentially what that is the practice of automatically deploying this new software to the environments that you're targeting, right? In this case, this image is showing that we're building a Docker image artifact, and then we're going to deploy it to a Kubernetes cluster, which will then make it available to your active users. Now, we all generally work with happy path deployments, right? And this is basically where all the jobs successfully complete, right? So you have everything from writing the code, pushing it up to your code repository, and then your CI/CD pipeline, kicking off and doing all the things that you've defined within your CI/CD pipeline config file, and then at the end of the day, it's just exposing your code or deploying your code to Kubernetes, and then exposing that code to your users so that they can use it within your services. Now, I can tell you that, when you're having these deployments, some of the pre-deploy results, especially within CI/CD pipelines, can be deceptive. Obviously, right, deployments always fail unexpectedly. I would say always, but they predominantly fail unexpectedly. And that's okay, right? That's kind of common practice. And in this diagram here, right, I'm showing you that, my pipeline kind of went through all the stages. It deployed my Docker image to Kubernetes. But once it deployed, which there was no problem with the deployment, the application didn't maybe start up properly, or it's just not functioning as designed, which then impacts, right, the users being able to access this new functionality in our deployment. So here are some of the common post-deployment failure reasons, right? This is a big one, defective configurations, right? How many times, I'm sure as a developer, we've all faced this, right? Where, something has changed in the target environment, right? But we as developers don't understand what that was, or are completely unaware of it. And we have to go back, right, and reconfigure the configurations for our application. So that's a big one. The next one is an integration fault, which I consider an integration fault to be a situation where, like, maybe you're connecting into a third-party API or third-party database, and maybe that service that you're connecting to is just down, right? Maybe it just had an issue that day, or there's something going on with the service that's basically out of your control, right? And it's the service that you're integrating with that you don't control and you were unable to fix. The other deployment failure reason could be invalid credentials, authentication. This is actually one of the more common ones, right? So like maybe an API token has expired or has been revoked, or maybe just have wrong password and username. Whatever the case may be, these are the three more common deployment failure reasons. So now that I described kind of failed deployments and especially within a CI/CD pipeline and the different reasons why things are failing, let's take a look at how we can leverage CI/CD and infrastructure as code to help reduce the amount of failed deployments. So, in this day and age, we're expected as developers and DevOps engineers, or anybody pretty much in the technology field regarding code, we're expected to go fast, confidently, and reliably. That means, we're writing code at record pace, and then we're also deploying that code, at the same time almost, right? So when we're going fast, confidently, reliably, we want to be able to do that, keep keep our release cycles up at a very good velocity, but we also want to be releasing, reliable code or code that's of quality and not bugs. So here's another example of we saw earlier, the failed production deployment, whereas we're running a CI/CD pipeline up until the point where we're building our image for our production deployment to Kubernetes. And again, the application deploys in this diagram, and then once it's deployed, the application is not functioning as expected. So what I'm proposing here is, in this diagram, is everything's up and the same up until let's say it's a pipeline that developer has pushed some code, it's built the image, and in this case we're going to leverage infrastructure as code to create a Kubernetes target environment. Then we're going to deploy that application change in the form of a container, and then we're going to smoke test those deployments, right? And then once all that kind of has passed my tests, we're going to destroy everything, right? The Kubernetes cluster, we're going to destroy the container services, all the things that were created in that create target environment step. So what that gets you is basically the ability to know that your application has been deployed to the target environment, and then smoke tested, and then you can destroy all that environment because you don't need it, right? And again, this helps with the release management of that product. So your release managers know, hey, these code changes were packaged, deployed to a Kubernetes cluster, they were tested, it works, and we can basically have a higher confidence in that deployment. So this is a diagram from the Circle CI dashboard. Just shows you a quick way, right? And this is also in my demo. So, but basically what I'm showing you here is that you can run things in parallel. They're all connected, right? To a point where you have dependencies, especially when you're deploying to Kubernetes, you have to create a cluster to do it. And then finally, we're going to run some smoke tests and then destroy everything that we've created, so that, we don't need that infrastructure around. And then your artifact in your pipeline is kind of verified, and your application release management team just has that extra kind of factor or good feels in knowing that this has been run on a Kubernetes cluster. So again, when we're implementing these things, we're going to deploy the application, use smoke tests to test the application within its target environment, so we understand and know that we're seeing the results that we're expecting. It also helps with developing fast pipelines that you can smoke test, again, all your releases, and you can leverage infrastructure as code to create and destroy these target environments very easily. I would highly recommend that you start, if you're not already doing so, researching infrastructure as code. There's plenty of tools out there to help you get started, but it's definitely something that I think all developers in the future will need some sort of competency in, to understand how to get their code changes from they're basically your laptop or your code repositories out into the real world and into some real infrastructure. With infrastructure as code, also, not only getting that ability to kind of test your code in real environments, you can also manage and control the changes within your target environments using infrastructure as code. So again, this is a concept that's not going to go away. It's actually probably going to become even stronger as time goes on in the industry. So just wanted to share the benefits of smoke testing before I jump into the demo. Again, you're going to gain valuable insights into your deployments and your application releases. It's an easy way to expose any kind of missing bugs, So if you're just deploying things or writing code and you're not testing, you're probably not catching any bugs. So, try to look at using at least some unit level or smoke tests to kind of get you in the habit of, catching these bugs before you're releasing them into the wild. And you're also verifying your application behavior, within those target environments where they're going to be deployed to. And finally, reject all failed software releases, they're great to know that you had issues, but obviously you don't want to be packaging those failed releases up into a artifact and then deploying that into Kubernetes. So now let's jump into the demo and show you how all these concepts kind of come together. So I want to start the demo now. What I'm going to do is show you some code. And in this code, what I'm going to show you is the application. So this is a simple, Node.js static website. And it's basically just the example project I want to use. So we're going to trigger my pipeline first. And then what we're going to do is in that pipeline is do a bunch of testing and then also deploy this application to a Kubernetes cluster, as well as test the application within the Kubernetes cluster that we create using infrastructure as code. And then that will give us, right, the smoke test good feels that we need to ensure that that release is as quality as possible, right? We smoke tested that deployment inside of a Kubernetes cluster. So let's go ahead and update this to version 6 of the application just to trigger our builds. I'm saving it. So now we need to go ahead and trigger, or at least commit this, right, to GitHub so that we can trigger our build. So let's go do a git status, here. We're going to do a git commit, and then we're going to say commit app.js, give it a message, right? And then we're just going to say updated version number. Of course, we need to use a lowercase m. Once we have that, we're going to push this to GitHub. So we're pushing our changes to our shared repository, right? Which is master. Then we're going to go ahead and jump into the Circle CI dashboard, which basically shows that we've kicked off some jobs here, right? As you can see, if we drill into it, this is a Circle CI dashboard. It's showing me my pipeline build, right? And as you can see here, right, I have 4 jobs running. The most important bits here are this scan and push Docker image. So it's building a Docker image based off of that application. And then the create Kubernetes cluster so that we can deploy, right? Next step is to deploy that application and that Docker image to this Kubernetes cluster. Once we do that, then the following test is going to be a smoke test of that Kubernetes deployment for that application. And if all of those things pass, we can then move on to a manual step that I have here, which will destroy that infrastructure, right? So this is a manual button. We kick it off, and then we'll basically kick off a destroy job. Great. So now our deployment has been deployed using infrastructure as code and our pipeline. And what happened here was our smoke test ran, right? So we now have our smoke test job. And basically what we're doing is smoke testing our deployment. As you can see here in these results, we basically have this endpoint, which was created again by infrastructure as code in the DigitalOcean system. And we're going to go ahead and just test the application is actually up and running right in the Docker container. And there's our version number 6. We also have this text that we're looking for in our smoke test. So if you look here, we got the OK200 response. And now we also have the assertion test, which basically is looking for this test or this text within the web page, which we certainly have. Now, once we take a look back at our pipeline, you can see here that I have a button to destroy this. Now, again, normally in an automatic pipeline, you wouldn't have this manual step. I just have it here for demo purposes. But imagine this would be gone, and then this would just kick off automatically once the smoke test is done. Again, this is basically a way for you to increase the confidence in your releases and basically test your deployment situations to whatever target environment that you're going to deploy to, right? So in this case, we deployed to Kubernetes. We built the application into a Docker image. We deployed that Docker image, and then we ran smoke tests once the application was deployed. We know that this application will run pretty smoothly within Kubernetes, and that's basically the point I'm trying to make here. All right, so that's the end of my talk and the demo. I hope you've all learned something, and I'm definitely interested in learning what you have, some comments or some questions for me. So let's jump into the Q&A session.